Hi everybody, my name is Anirudh Sharma. I'm the founder of Magnetogenics, and my goal through this startup would be to increase the supply of transplantable organs and tissues by innovating technologies that enable long-term organ preservation. So much like organ banking in a sense. And so at the very core of this company are two technologies. One is cryopreservation that would enable long-term preservation, and electromagnetic rewarming that would help damage-free recovery of these organs from the cryopreserved state. So currently the team is just me. I'm a postdoctoral fellow here at Johns Hopkins University, and my PI, Dr. Robert Ivkov, who would be serving in an advisory role. So why am I pursuing this problem, and what problem am I really addressing with this? If you look at recent data by the Organ Procurement Transplantation Network, you'll notice a large percentage of organs are discarded every year. For example, 20% of kidneys are discarded every year that are otherwise transplantable but are lost to poor storage methods, for example. And so that's a problem because every year 30,000 new candidates get added to the existing waiting list, increasing the pressure on the supply of organs that are transplantable, so we can't lose 1 in 5 organs to poor storage. So the current clinical standard for organ storage after it's been harvested from a donor is storage on ice that only allows 6 to 18 hours depending on the organ. And there are several companies like TransMedics and OrganOx that are looking on optimizing those hours of storage. There are other research groups that have looked at supercooling down to a temperature that would allow extension of preservation to days. Most everyone has stayed away from going to the cryogenic temperature range, which is down here in the minus 150 region, because cooling and rewarming induces ice if your processes are not optimized. And so what I'm presenting is a technology that would enable us to do exactly that, to tap into this region using processes that would outrun ice. And I've extensively published on these processes. If you are interested in reading more about this technology and the technical details, I've cited the papers that I've published here recently for preservation of kidneys and livers. And essentially this flowchart indicates that instead of doing an outside-in cooling and warming, what we're focused on is doing a whole volumetric cooling and warming that enables us to outrun ice. And the beauty of this process is that it is scalable, that you can go from smaller biologics to all the way to organs. So the organ preservation market size was valued at 200 million globally with a compound annual growth rate of about 6%. But if we were to include the cell and tissue preservation market, the value is 10.04 billion with an 11.9% compound annual growth rate. So my business model proposes selling a medical device that makes this cryopreservation and recovery process possible, and therefore allow preservation of hearts, kidneys, and livers, as well as precision cut tissue slices. My core customers would be hospitals, biopharmaceuticals interested in drug screening, research labs interested in fundamental studies, and organ procurement organizations eventually transplanting these organs once validated. In addition to the device, we'll be selling workflows, which include both preservation protocols and matching protocols, as well as banking repositories and AI-based organ matching software that would optimize the current matching process. Finally, a few current status updates. I filed an invention disclosure with JHTV. I published preclinical work in high-impact scientific journals on this technology. I've applied to various funding mechanisms both within and outside Hopkins, and pending our funding situation, we'll be looking to expand our team beyond just the two of us. My email is down below, so please feel free to shoot me an email. And finally, I'd like to thank you and this program for an amazing experience. I've learned so much, so thank you.